And I'm going to pretend that I understood everything he said, but maybe not everything. So, my name is Stijn. I am a technical evangelist at NewRelic. I was the founder and CEO of a company called CoScale. And at CoScale, we were offering a monitoring platform specifically for Kubernetes, Docker, microservices. My company was acquired by NewRelic in October last year. And today, I've taken on a role as technical evangelist, so I like to talk about all of the great possibilities there are in the market. I like to talk about microservices, containers, Kubernetes, everything related to those upcoming cloud-native technologies. I'm originally from Belgium, but NewRelic has an R&D office in Barcelona, so we moved our team, about 10 people, to Barcelona, where we're actually enjoying life. It's not bad at all. So we're going to talk about observability, and of course, because of my background, I'm really going to zoom in a bit more in microservices and in Kubernetes today. So I've heard that a lot of your teams are working with containers, with microservices, with Kubernetes. So a quick poll. Who is today using or moving towards containers and potentially Kubernetes? Okay, so that's almost everyone, I think. Great. So hopefully this will be an interesting session. But before we jump into observability, why are we here? Why do we care about observability? Well, expectations of your customers, of our customers, are higher than before. That's why we think, or we take observability so serious. We want to do our very best we can to serve our end customers, right? This is the same for you, this is the same for all of our customers. And there are some specific challenges around that. So what we want to achieve as businesses is we want to develop new software, we want to bring products as quick as we can to the market. We care about the user experience. So we want our users to have a flawless experience on our web applications. If one of your users goes to the website and wants to get an invoice for an insurance, we want them to have a great experience. We don't want the checkout process or the payment process to stall or not to work. No, we want it all to work flawlessly, seamlessly, because then that customer will come back, will recommend your service to other people, etc. Because in the end, that's what delivers us business value. So at NewRelic, this is what we care about. We want to help you to become successful. We want to help you to meet your service level objectives. We want to help you to achieve 0 errors or almost 0 errors. I mean, we all make mistakes and developers keep writing bugs and systems will fail, but we want to help you to achieve as little errors and as little downtime as you can. And of course, we want to increase the user experience, so we want to achieve sub-second response time. We want to make sure our applications work very quickly, they serve our customers very intuitively. So, what do we believe we need for observability? First of all, we need to measure everything. And in a way, at NewRelic, we don't even care anymore where the data is coming from. I mean, data is becoming such a commodity. If it comes from Prometheus, StatsD, JMX, if you're pushing it via an API directly to the platform, it doesn't matter where the data is coming from. But you want to instrument all of the layers that are important in your stack. And this starts with your end user, with your customer. So you want to understand, how is your end user using your applications? How is it visiting your websites? Via a browser, maybe via a mobile Android device or an iPhone. So you want to be able to measure that, measure the experience at your end user. And of course, then you want to understand all of the layers that are in between your end user and your infrastructure. So your application logic, your middleware, your databases, your containers, your virtual machines, your hosts, they could be running on-prem, in a private cloud, or even in the public cloud. So in a way, we don't really care anymore where you are generating data, where your workloads are running. We just want to capture all that information. The next thing we're going to talk about a bit is context and curation. Because we want to capture all of that information, it's important to make sense of the data. So we want to give as much context to the data as we can. If a user is unable to buy an insurance product online, why? Did we just release a new version of our product? Do we have a storage server failing somewhere? Like, we want to bring in context of all of those data sources and correlate the data together. And that's actually also what the last point here is about. That's about applied intelligence. So how can we use machine learning techniques to automatically analyze all of the data and make sense of it? If a storage server goes down and it impacts, let's say, 10 nodes, with each 20 containers on those nodes, you might have 200 containers failing. Do you want to get hundreds of alerts? No, you want to get one alert. Storage is down, it's impacting these servers, it's impacting your users. So that's what we mean. This is an example of where applied intelligence can be a benefit. So, if we talk about instrumenting everything, what is there to instrument? So we have our applications. This is where NewRelic typically uses an APM agent. So this is a piece of software that you install on your server, and it will monitor your Java application, Node.js application, Python application, whatever you might have running. We also care about your hosts. And as mentioned, they could be running in the cloud, it could be in your own data center. NewRelic has integrations with the cloud provider, so if you're deploying on or plan to deploy on AWS in the future, we can capture information from your virtual machines around CPU consumption, memory consumption, etc. And of course, we care about the services that run on these hosts. So we care about the databases, load balancers, message queues, all of the technologies you use in your environment. So within NewRelic, we have integrations for a wide variety of these technologies that allow us to capture data via our agent. But of course, we also want to support all potential third-party data that you might want to send to the platform. We talked earlier about technologies like Prometheus, StatsD, Telegraph, etc. So this is all supported by the NewRelic platform. And what this gives us is we talk about 4 important categories. We sometimes kind of abbreviate it to MELT. We talk about metrics, we talk about events, logs, and traces. And we talked a lot about metrics, we talked a lot about logs and traces today. Maybe just one thing I want to call out here is that we are seeing events as like a different category, because an event can actually be, for example, like a marketing campaign. It could be a deployment of your CI/CD pipeline. It could be any type of event that has an or potential impact on the performance of your business. So it's a bit broader than purely focusing on like performance events or a process restarting or a log line being generated. Okay? Now talking about context and curation. Relationships are important. We want to understand what's happening. If we have 10 containers serving or responsible for handling requests for service A, we want to understand where are these containers running. Are they all running on one physical server, or are they spread amongst our data centers? If there is an issue with an application, are all of my containers impacted, or is it just maybe one container on a specific host that is impacted? So we want to leverage the relationships that are inherent in the data as much as we can. And a bit later, we'll do a live demo, and I'll show you exactly how we do this in the NewRelic platform. And then finally, because we're capturing thousands and thousands of data points, of metrics, logs, we want to make sense of the data. So we want to get rid of the noise in the data. We don't want to generate 500 alerts and for you having to scan through all of these alerts, trying to make sense of what is now really causing the issue. So this is where we're applying artificial intelligence and machine learning techniques to automatically make sense of the data. And maybe I'll show an example of this during the demo as well. So this was a bit in general talking about observability, but I would like to dive a bit deeper into what do we need to monitor in a Kubernetes environment. And there are a lot of things going on in a Kubernetes environment. So we all understand the benefits that Kubernetes brings us. Like, it allows us to scale much more rapidly. We can easily shift our workloads. We can use our underlying resources much more efficiently. But there are serious challenges. We have a lot of different components in our Kubernetes cluster. So for example, we have our containers, and in Kubernetes we usually talk about a pod, and a pod can have one or more containers. And these pods, they live around your environments. Kubernetes is responsible for automatically starting these pods. They will automatically restart them. For example, if it hits a memory limit, they will automatically schedule them to the cluster. So there is a lot of dynamic behavior happening in these Kubernetes environments. You have your applications running inside your pods, inside your containers. So you care about the performance of these applications. All of these pods, of these containers, are running on nodes, and as mentioned earlier, they could be running in your own data center or in a public cloud environment. And then finally, how does my end user experience impact the performance of my infrastructure, but more importantly, vice versa? How is the performance of my Kubernetes cluster impacting my end user? If something goes wrong in my backend cluster, I want to understand how it is impacting the user in order to be able to solve it as quickly as possible. So let's talk about a few specific things that I believe are important to monitor in a Kubernetes environment. So first of all, if you think about the cluster as a whole, you really need to understand where are the pods running, because of the dynamic behavior of these clusters. Now, on top of that, you want to understand, did Kubernetes schedule all of the pods? If there are not enough resources available in the cluster, the pods might still be in the pending state, which will undermine the performance, of course, of your applications. Which nodes have resource issues? If there is a node, for example, with memory contention, with a lot of memory pressure, this might be impacting other containers running on the same node. And for example, how many capacity do we have left in our entire cluster? What's really important here is, and I stress this with a lot of customers, is the use of memory, or more general resource limits and resource requests in a Kubernetes cluster. So in Kubernetes, you can say, okay, I want this namespace only to consume that much resources. And this allows you to properly do capacity planning. It allows you to track, okay, how many resources is each team consuming? And if a team is hitting its memory limit or its storage limit or CPU limit, it allows you to plan for further capacity. So all of this data, of course, it's important that you capture it, and that you're able to act on it if something goes wrong. Now, because we're talking about microservices, we have many different components that are communicating with each other. So we're breaking down our traditional monolithic applications into smaller microservices, and they're all sending network packets to each other. They might be contacting third-party APIs to get some data, etc. So how are these interconnected? How much time are you spending in each layer of your application tier? And that's really what distributed tracing is about. And I'll show this during the demo in a bit as well. It is important to understand where you're spending the time in your entire stack. And if a specific component is impacted, you will be able to detect this or easily see this in a distributed trace. The next thing we care about are the pods and our deployments. So, I mean, you're all familiar with containers and Kubernetes, I guess, most of you. So when we define a new deployment, we're telling Kubernetes, hey, I want to have, let's say, 10 pods of this specific container image in my cluster. So that's basically like a deployment. So we have to make sure that we have those 10 containers running in our cluster. We want to understand where they're running. We also want to understand, are there any issues with the containers in these deployments? For example, are we able to retrieve the images from our image repository? Is any of our containers crashing? We often see this with memory leaks. So you might have a memory leak, and then eventually your container hits the memory limit. It's killed by Kubernetes, but the beauty of Kubernetes is it will automatically restart it. So if the memory limit, let's say, happens every minute, you'll have containers restarting, stopping, starting all the time, over and over again. So that's something you definitely want to keep an eye on. And then, of course, the applications running inside the containers. So what applications are running where? What is the performance of the request? So how fast are we answering? What is the latency of each request that is being sent to our containers? And if we group our applications by namespace, how is my namespace performing? Do we see differences between namespace A and namespace B, etc.? And then finally, the end user experience. So we'll talk about this later during the demo, the importance of, again, measuring the end user experience and in correlation with the rest of your environment. Now, earlier this year, we launched a new product. And I mean, coming from CoScale and having worked in the APM space, the monitoring space for many years, I'm really excited about the announcement of NewRelic 1. So NewRelic 1 is what we call an entity-centric observability platform. And I'll show during the demo what exactly an entity is. But think of an entity as anything you care about. It could be a server, it could be a container, it could be an application, it could be a user, it could be a load balancer, it could be a message queue, anything. So that's an entity. And in NewRelic 1, we make it very easy to search through these entities, to correlate entities, and to understand what's happening. I'll give a demo about this right now. So, I haven't prayed to the demo gods, but we're just going to do this. So that's an interesting observability exercise. You can watch me, and if I get more nervous, it means that the demo is not working. We'll see. Let's start with this one. And maybe I can put this full screen, or just a little bit. All right. Good. So let's start with this. So we were talking about Kubernetes. And this is a Kubernetes cluster. We call this the Cluster Explorer. And I'm a fan of this visualization. It allows me to quickly see where we have problems in our cluster. And let me explain you what we're seeing right here. So this pie represents our cluster. Each slice of the pie represents a node in our cluster. We use color coding, like traffic light way, to indicate if something is going wrong. So you can see if we move more towards the center of the pie, we have containers that are having problems. In the outer ring of the pie, we see the containers, or the pods in this case, that are running perfectly fine. So let's have a look. So what I can do here is I can hover over any of these elements, and I will start from the outside. So if I hover over this, I can see this is a host in my cluster. We can see a summary of its CPU consumption, memory consumption, and storage consumption. And then if we move towards the inner circle, we can see, hey, we have a pod running here. It's our DNS controller. But there are also other pods running on this node that are having problems. So we have our cluster autoscaler, we have a lot of different services running in our cluster, and we're summarizing some of the data in this cluster. Now what you can do next is, you can actually drill down on any of these pods to get more details. So let's hope that the connection is good enough. It's quite good. So if I click on any of these pods, I get more details. And in this case, what we're seeing here is that we're seeing the resource consumption of this specific pod that I clicked on. So there is one container running in this pod, so that's why we see one container here. The blue line represents the actual resource consumption. So in the left case, CPU consumption, right, memory consumption. The yellow line represents the resource request, and the red line represents the resource limit. So if we look at the memory, we can see something interesting here. So we've requested 67 megabytes from our Kubernetes cluster. So I want to ask for 67 megabytes, and I'm telling Kubernetes this pod should not consume more than 150 megabytes. So that's the red line. And as you can see here, the blue line is actually getting close to the red line. So that's actually, in this case, why this pod is marked in yellow. Now, of course, you can get alerts and other things for this as well. But that's a first example on how you use the Cluster Explorer. If we move more towards the inner of the circle, we see two pods here. And these are pods that are in the pending state. So it means they were not scheduled in our cluster. And the question is, of course, okay, why? In this case, as we can see here, looking at the status and the reason, we can see that an invalid image name was provided. So maybe our Docker repository in production is out of sync with our repository in our staging environment, as an example. So this allows you to understand that. Now, of course, we understand that Kubernetes environments grow, become more complex. You have a lot of pods, a lot of namespaces. So you want to be able to easily filter in this view. So at the left-hand side here, you can see some filters. So for example, in this case, we see some different namespaces. And for example, in this case, we have 21 different deployments in this environment. So if I pick a specific deployment, I'm zooming in, and I'm now seeing, okay, we have, in this case, we have 6 pods running for this deployment. And these are the virtual machines or the hosts where the pods are running on. And let's click again on one of these pods. Now, in this case, we've actually detected that there is an application running inside the service. It's an application that NewRelic can automatically instrument. So that's why you get this nice overview here at the bottom of this side pane, which summarizes the application performance of the service running inside that pod. So you can see, in this case, the transaction time, throughput, and a summary of the error rate. So this is really gold. I mean, it gives you application performance information in the context of your Kubernetes cluster. This is really important and very powerful. Now, if you want to get more details, if you want to dive and analyze the performance, the application performance in more details, you can click on any of these links here. So for example, if you want to jump to the APM portal, you can do that here. So by doing this, we're zooming into the specific service that was running in this pod. And in the APM view, we can analyze the application performance in much more detail. So for example, what we see here is we see the transaction time that is being broken down. It's a Java application, so you can see that we're spending some time in garbage collection, some time in our middleware. Oh, sorry, it's a Ruby application. Some time in our Ruby execution engine, etc. In the right-hand side, the right top side here of our APM overview, we show what we call the Apdex Score. An Apdex Score is basically one number that tells you what is the quality of service of my application. There are some parameters behind the scenes that you can use to tweak this score, but it basically allows you to see over time, how good is my application service performing. We have some other details here. Now, as you might have noticed, we also had a link to distributed tracing here. So let's have a look. Let's click on distributed tracing. Okay. Maybe I need to, on the gong, to wake up the gods. I'll try reloading it again. So what we should see in a minute here is, so for each of the services, okay, here it is. So for each of the services that are being called, we are, so basically, as was explained earlier, there's a transaction ID that is being passed along. We have a span ID for each individual kind of where we're spending time. And what we see here is each dot in this overview represents a single distributed trace. But a single distributed trace touches multiple components, multiple spans. At the bottom here, we see an overview, so a table of all of the distributed traces that were captured here. And so, for example, what we can see here is that the top one here, touches 14 different services with 300 spans. So, okay, let's dig into this. Let's have a look in a bit more detail. So, the total duration of this span, so end-to-end, is 3.3 seconds. And then we can see, okay, how much time are we spending in each of the different services here? So for example, we can see that we're only spending 55 milliseconds in our preparing order call of the order status service, and etc. So this basically allows you to understand how much time you're spending in each of the services. Now, because NewRelic has grown over the years and originally started as a pure APM vendor, we actually have more detailed information here. So this is typical tracing information that you see. But what you can actually do here is you can actually enable what we call in-process spans. And this is the typical APM bytecode instrumentation, for example, for Java applications. So what you see here is, in this case, a call stack. So a request was done from service A to service B, so to the service order status in this case. And then within the execution of the Ruby code, we can actually follow the stack trace. So we can actually see in the code where we are spending our time within that service. Right? So this is powerful. It's combining distributed tracing across our traces with APM bytecode instrumentation, or APM code instrumentation in general. Make sense? Right. Good. If you want to get more details, you can also click on any of these spans. You can look at how is response time changing over time. You can also look at specific attributes. So for example here, this specific span was captured on this container. The cluster name, the pod name, the deployment name will also be in here. All right, cool. So, good. Now, so I was talking about the filters and about the drill down. Now, of course, if you have hundreds of nodes, or maybe hundreds of clusters, we actually see more customers now moving towards smaller clusters and more clusters than gigantic Kubernetes clusters. So, at the top, you can switch between clusters. We also have an overview page that gives you a summary of all of your clusters. But what we're doing here in this view is, if you have, let's say, 100 nodes, we will summarize the nodes that have issues. So we will pinpoint you towards the interesting data, the containers that are having problems or the nodes that are having problems. And at the bottom of this dashboard, you will get a complete table with all of the data. Okay. We also, of course, have a more traditional kind of a metrics-like dashboard, which summarizes some of the important metrics of a Kubernetes environment. For example, the container restarts is an interesting one, as I mentioned earlier. One very interesting use case, and someone talked about readiness probes and liveness probes earlier today. Something we've seen earlier is, if you define a readiness probe, you have to make sure there is a parameter, it's something like initial start delay called. Like if that parameter is too small, Kubernetes will execute the check, the readiness probe, before your application is ready. Imagine you have, again, a JVM application. It takes time to start up the JVM. If you execute the probe before the application is ready, Kubernetes will already kill it, start it again, and you will be in an endless loop of these problems. So that's something typical we also see happening. Okay, good. Yes, let's look at a few other things. The first thing or the next thing I wanted to talk about is more in the context of end user performance, end user monitoring. So what we're looking at right here is we're looking at performance data that is coming from the browser of our end users. What we see here is we see an overview of our page load time that is broken down into the time we're spending in building our DOM, page rendering, the network latency basically, and the time we're spending in our backend so that's the web application one, so the time we're spending in our backend to basically fetch the calls. So this is tying all of the data together from the view of our end users. Here again you get an Apdex score, throughput, and of course because we capture all of the data at the end users, we know which browsers they're using, geography, so you can actually easily filter by, for example, by browser. If there is a specific issue and you want to understand is it only happening on Chrome and not on Firefox or something else, you can actually easily zoom into this right here. What you can do is you can then also drill down into specific page views. So for example, you have a specific web page that you're interested in, or suddenly you see a spike in the latency for this web page. You can actually zoom into it and analyze it in more detail. So what you will then see is then for this specific web page, we've also captured traces. So and a trace is really tied to a specific user, one session, and that's why we call it session traces. And you can then analyze these session traces here as well. So a session trace is somewhat similar to a distributed trace, but here you can also see all of the data from your browser. So for example here, when are you doing a DNS lookup to the DNS lookup start, domain lookup end, the rendering times will be here. So you see the load event, the unload event here. You see when your JavaScript resources are loaded, when you're making requests to your backend services, etc. So we're visualizing all of that data here as well. Okay, yes?
Can you show us how you monitor the end user behavior from different regions? Because
let's see.
it's one of the major sellers points for my
Filterable geography or geo. So like I said, all of and this is automatically done based on IP ranges basically. So what you can see here in this case is, okay, there are a lot of users using our application. They're coming from different cities, different geographies. And this is an example of a map where you can see, okay, what is now the performance in the US compared to Brazil, for example. And it's being summarized here. So as you can see in Brazil, so for some reason in Brazil and Israel, there is the delay is higher, potentially maybe network latency, versus in the US. So that's an example of the geographical data and how you can use it to understand performance across regions.
But you also have the ability to place the agent in different locations. So maybe can you show this?
So just to clarify, so this is real user monitoring. So these are real users. We also have something called synthetics. And synthetics, I wasn't planning on showing it, but I'm happy to do it. Synthetics is basically where so this is typically called synthetic monitoring, where you basically have like a robot that is sending a synthetic request, faking a user. And what you can do there is you can basically define, okay, from where do I want to send this request? So we have, synthetic, how do we call it, probes all over the world. I'm not sure if this is a good example here. Let's have a look. Yeah, so here you can see, so for example, in this case, there is a specific synthetic check. It's being performed from 5 different locations. So you can then see, okay, what is the check from Paris or from Dublin or whatever. Yeah. Okay. All right, now, yeah, going back to one of our observability challenges was, okay, how do you find the needle in the haystack? How do you, find something in the wealth of information that you have? So I talked earlier about our entity-centric observability platform. And this is kind of the home page of NewRelic 1. And the first thing you do, or you have here, is a search bar. For us, it's really, this is the Google search of performance, of everything you care about relating to your applications and your infrastructure. So the reason why we think this is important, what we've seen in larger enterprises is that there are so many different teams, so many different applications, technologies being used, and one person or one team might be responsible for a lot of different things. So it becomes a challenge to find and to correlate data. So the first thing you can do actually here in the NewRelic 1 interface is just type something. For example, I know that I've worked on a portal. Like we were creating a portal, so what I can do is I can type portal. And if the Wi-Fi or my connection is somewhat okay, I will get like a summary of all of the things that are related to portal. So in this case, I see there is a service. Oh, it's one of my favorite services. So you can start it as well. There is a dashboard, there is a browser application, so there are many things. If you want to see everything related to portal, you click on this Browse All button, and you get an overview of all of the results that are relevant to portal. So there are 7 services, there are some applications, dashboards. There is apparently an ELB load balancer called portal. So we will index all of the entities coming from AWS, whatever provider you use. So you can easily drill down. Now, let's, for example, then click on the web portal service. So if you click on the web portal service, we're taking to more details about the service. This, again, summarizes me, in this case, the performance of our web portal service with our transaction breakdown, throughput error rate. From here, we can also jump into our distributed tracing. And something I think that was mentioned by someone else earlier before was the concept of building service maps. And again, this is really important because we have so many teams, the applications are communicating with each other, we're making a request to maybe a third-party service. It becomes a challenge to really understand what your service or map looks like today versus a week ago. So in this case, what we see is a view of, okay, what are the dependent services for my web portal? So we can see that the web portal is communicating with the fulfillment service, inventory service, and these other services, which again, of course, you can then drill down into and analyze in more details. Okay. All right. So that went quite well, the demo. Not too many hiccups. So I would like to conclude with this view. And it basically describes the NewRelic platform. And NewRelic was founded a bit over 10 years ago and became very popular with APM, so deep dive application performance monitoring. But today, NewRelic has much more to offer. There is end user monitoring, understanding the performance of the end users, real end users or synthetic fake end users. There is the deep dive application monitoring, and there is infrastructure. So all the Kubernetes data I showed, AWS metrics, visualization, all of that, that's all coming from our infrastructure agent. And then basically what you've seen during the demo were our dashboards. I didn't show any alerts except for in the Kubernetes Cluster Explorer where we used like color coding. We also capture logs, so if you're interested to get more details about our logging product, come talk to us. I didn't include it in the demo today. And then I showed the maps and the traces, so basically all of the components you need to monitor your entire stack end to end. That's it. Any questions?